Thank you, Chairman, for giving me introduction. To begin with my presentation, a brief background on rabies. Rabies is a fatal viral zoonotic disease caused by RNA virus of the family Buiatrics. It's highly prevalent, especially in developing countries of Asia and Africa. The disease is responsible for over 59,000 human deaths and an economic loss of over $8 billion a year. And 6% of these losses are attributed to rabies in livestock. Rabies is preventable by vaccination, but cattle and other livestock animals are not vaccinated against rabies due to high cost of vaccination. So we wanted to find out if a low-dose intradermal rabies vaccination can produce antibody titers as good as the standard intramuscular rabies vaccination that is practiced in some countries. Now, this intradermal rabies vaccination is commonly used in humans to prevent rabies and as a cost-cutting measure. However, intradermal rabies vaccination is not commonly used in cattle. There are very few studies that compared intradermal rabies vaccination to the conventional intramuscular rabies vaccination. One of the studies used 1/5 of the intradermal, 1/5 of the dose that was used intramuscularly, and they showed that using the 1/5 dose that was used in intramuscular to produce protective VNA titers as good as the standard intramuscular route or even better. But the sample size was small and the response to intradermal rabies vaccination was variable. So we wanted to find out if 1/5 of the dose of intradermal rabies vaccination that is used in intramuscular is true, is as good as the intramuscular rabies vaccination under Bhutanese field conditions. Now, why Bhutan? Bhutan is a small, tiny nation sandwiched between India and China, and it is also highly endemic to rabies. Mainly because we have large number of free-roaming dogs, approximately 120,000 free-roaming dogs. That is one dog for every 2.5 cattle. So we have humans, cattle and dogs, we live in a community, so contracting rabies from dogs, which is our main reservoir host, is of high risk. So also the cattle rearing system in Bhutan, that is free grazing. More than 70% of our cattle are free grazed, so that also increases risk to rabies from dogs. Study design was a non-inferiority trial. The study site was Bhutan, in the Ha province of Bhutan, that is northwestern part of our country. This province has 6 sub-districts, and we had chosen 3 sub-districts for the study. Coming to our methodology, farm and animal selection. So for this farm and animal selection, we had taken data from our annual livestock statistics, and so we had entered all these data into an Excel sheet, and we excluded all those farms that had less than 4 cattle, because we wanted 25 farms randomly selected to get a minimum of 100 cattle. However, when we commenced our study, 2 of the farms could not fulfill our criteria, so we had to include 2 more farms. So out of 100 animals, were divided into 3 groups. Group A, 45 cattle, administered with 1 ml of the Raksha-Rep inactivated rabies vaccine intramuscularly, and Group B of 45 cattle with 0.2 ml of the same vaccine intradermally, and we had 10 control animals that were not vaccinated. And serum samples were collected on day 0, that is day of vaccination, 14, 30, 60, and 90 days later. The serum titer were calculated using fluorescent antibody virus neutralization test. So coming to the results, our result was, so we compared intradermal and intramuscular response to rabies vaccination using two titers, two protective antibody titers. The first one we used was 0.5 IU per ml. That is the titer cutoff point recommended by WHO and OIE for rabies vaccination. So we can see here that 40 out of 45 animals in the intramuscular and 31 out of 43 cattle in the intradermal group had titer greater than or equal to 0.5 IU per ml, and there was no response in the control group. We also looked into the antibody titer kinetics, and here we can see that a classical antibody titer curve was formed with almost a zero titer on the day of vaccination. And as the days passed by, the antibody titer increased with a maximum titer on day 30 for both the groups, and so day 30 onwards, the titer level decreased, and by day 90, the titer levels were minimum in both the groups. Now the second comparison that we made was based on the VNA titer, this virus neutralizing antibody titers greater than or equal to 0.24 IU per ml. This titer was based on the vaccination and challenge studies that were carried out in many species such as dogs, cats, and cattle. So we can see that although the proportion of cattle with this titer was more in the intramuscular group, but it was not statistically significant. So coming to discussion, we can infer from our results that intradermal route of rabies vaccination was effective, but it was inferior to the intramuscular route because intramuscular route was significantly greater than the intradermal route. However, even with the intramuscular route, we can see that the protective titer did not last more than 60 days against the manufacturer claim of to last for 1 year. So we can conclude from this study that although intradermal rabies vaccination, it was effective in producing antibody titer response, but we cannot recommend intradermal vaccination without further studies. So further studies with increased dose or repeat vaccination is recommended. However, in our Bhutanese situation, repeat vaccination may not be possible because of free grazing of our animals. So we may recommend increased dose. These are my references, and I would like to thank New Zealand Development Scholarship for giving me scholarship to study in New Zealand, and OIE Reference Laboratory in France for testing my samples for free, and the Royal Government of Bhutan and Massey University for allowing me to conduct my study in Bhutan. Thank you very much for listening.